All right, graphing quadratic equations. Let's start off with y equals x squared plus 2x. Okay. So normally, I think probably last year when you first learned this, you started off with just y equals x squared, right? And that's called standard parabola guy and all that stuff. So I'm hoping that you remember some of that stuff. I want to do one that's going to walk us through the whole process. Okay. So we start off by looking for our vertex. And the first part of our vertex is called the axis of symmetry. The equation for the axis of symmetry is x equals negative b over 2a. So in this equation, a equals 1, b equals 2, and c equals 1. Right? A is right here. It's an invisible 1, b, and c. So our x part of our vertex, or our axis of symmetry, is x equals negative 2 over 2, negative 1. And we could draw the axis of symmetry on a graph as a dotted line. That would be our axis of symmetry. It's not technically part of the line, right? It's not part of the parabola itself. But it tells us if we were to fold our parabola in half, this is the line that we would fold it on. The vertex is either the highest or lowest point of the parabola, right? So parabolas either have a lowest point if they open upwards, or they have a highest point if they open downwards. And then they go on infinitely in the other direction. The vertex is the x-coordinate of the axis of symmetry, and then to find the y-coordinate, we simply plug that in. So y equals, taking my negative 1 and plugging it into this equation. So instead of x squared, I have negative 1 squared. Instead of 2x, I have 2 times negative 1. Instead of 1, I have 1. Negative 1 squared is 1 minus, because a positive times a negative is a negative, 2 plus 1. Remember, this will always happen. These will always be opposite in sign, and this will always be twice as big. So y equals 1 minus 2 plus 1, which is 0. I think. Yeah. So our vertex now, we have both coordinates is negative 1, 0. I can put a point there. Next, you can make a table of this, or you can just kind of say it to yourself. Over and up. In this case, there's a 1 in front of our x squared, so these are just going to be perfect squares of these. So if we go over 1, we go up 1. If we go over 2, we go up 4. We could keep going. Over 3, up 9, over 4, up 16. These are just these squared. For the purposes of graphing, you pretty much just have to stick with the first 2 sets of points. So on my graph, if I go over 1, up 1, I can put a dot right there. And then I do it on the other direction. Over 1, up 1, put a dot right there. If I go over 2, 1, 2, I have to go up 4. 1, 2, 3, 4. Remember, with this system, we're always starting from the vertex. So I go over 1 from the vertex, up 1 from the vertex. Over 2 from the vertex, up 4 from the vertex. Oops. And there's the reflected point. The other thing we should notice as we do this, you can kind of use this as a self-check. These points should be exactly symmetrical to these points over here. So here's my parabola. have to remember that it goes on forever, so I end it with an arrow to show that it's going up. And that's it. I've graphed a parabola. Okay. Let's do one that's a little different. Can I erase the equation up here?
Yeah.
Can I erase this first part here? It's ready? Pretty much. I'm just going to erase the things that are going to change. Tell me if I'm going down too far. Can I erase the graph? Okay. Awesome. Axis of symmetry, still the same equation, negative b over 2a. In this case, b is 4, so we have negative 4 over 2, because over negative 2, because a is negative 1. Our axis of symmetry is x equals 2. Wow. Wow. 1, 2. Dot, 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 dot. I don't really require that you draw the axis of symmetry on your thing. It can be helpful because on your graph, it can be helpful because it shows you where your symmetry is, right? It shows you how to reflect the points. But the real reason we need it is to do the vertex. So our vertex here is 2, negative 2 squared plus 4 times 2 plus 2, which is negative 4 plus 8. So again, opposite signs, this one's twice as big, plus 2, which I think, if I'm doing my math right, is 6. So our vertex is 2, 6. 1, 2, 3, 4, 5, 6. Okay. Now, you can either write this out or you can do it in your head. Except now I'm not going to go up. Why am I not going to go up? Because I have negative x squared. Whenever my a is negative, that tells me my parabola is opening down. So I'm going to go over and down because of this negative right here. Tells me to go down. And I'm going to go over 1, down 1. Over 2, down 4. Over 3, down 9. Except I'm not actually going to do that. To draw this, so over 1, down 1. Over 1, down 1, over 1. Okay, I didn't draw this quite well enough. Over 1, down 1 would be right there, right? Over 2, down 1, 2, 3, 4 would be right there. Right there. I think my axis of symmetry is a little tilted to the left. My line is not quite perfect, but something like this for my parabola. Is a parallelobola. A little tilted. Yeah.
Isn't negative 2 squared equal 4, not negative 4?
Okay, so this is a key distinction. I'm so glad you pointed this out. I have negative x squared, right? That's my original said this. So it's the negative of x squared. I could draw parentheses. Oops. I could draw parentheses where the x is, right? So it's negative x squared, which is negative 2 squared. The difference from the last one was we had x was negative 2 or whatever. I don't think it was, but if I have negative 2 squared, if the negative is part of the x, if it's inside the parentheses, that becomes a positive number. Because this means negative 2 times negative 2. This means negative 2 times 2. You guys see the difference?
Yeah.
If there's a negative in front of x squared, that has to stay out of the parentheses. It doesn't get squared. If there's a negative on x, like if I solve this and the answer here is negative, that will get squared away. Yeah.
In real life, will you ever come across, like, why do we make these things infinite? Because I don't think that we have that in real life.
What? So, like, why don't I just end right there? I don't think that you would ever come across one where you actually need it to be infinite, but how far do you want to go? You know what I mean? The farther you go, the more useful it becomes. And what we're practicing here is just showing me that you know that this thing keeps going. This equation is a line that just keeps going on and on and on and on and on. Right? So like, let's say you were building a program that graphed parabolas for you. You would want your program to graph it as big as the screen was. You would want it to go all the way to the edge of the screen. And then if the person like zoomed out, you would want them to see it keep going. So we're just showing with our hand drawing that we realize this would keep going on and on in those two directions. Yeah. And then the chances, you know, the chances of like, if you were using a parabola, let's say your parabola represents, I don't know, like the trajectory of the moon around the Earth or something, and you want to figure out how to make a spaceship launched from the Earth intersect with this trajectory. The chances that it's going to intersect in the first, you know, 4 kilometers or whatever is pretty low, right? So we would want to know, okay, if I have a line that goes like this or something, where is this actually going to intersect? So whatever my model is, oh, it's going to be down here, and then I can figure out where that is. But, yeah, so all you're doing is showing me you know that it goes on and on and on past there. Yeah, I'll never make you actually draw it all the way to infinity, though. That would just be mean, right? Okay. Let's do one more quick example. Oops. I hope I can erase this. Because I just did. Can I erase the graph? Yeah. Alright. What if A is some number other than 1 or negative 1? Let's say A is 2. Okay. Start with x equals negative b over 2a. Negative b is positive 4, because it's negative negative 4, over 4, because that's 2 times 2. So x in my vertex is 1. Okay? My axis of symmetry is 1. By the way, is this parabola going to point up or down? Going to open up or down? Smiley face, right? Up. No negative number here, so that's a positive. Okay, y equals 2 times 1 squared minus 4 times 1 plus 1. And this keeps happening. 2 minus 4 plus 1. Negative 2 plus 1 equals negative 1. So the y part of my vertex is negative 1. My vertex is right here. This is the only thing that changes when we have an A that's not 1 or negative 1. It's this little chart. We're going to go over, and then we're going to go up what we were doing before times 2, because there's this 2 here. So I'm going to go over 1, up 1 times 2, which is 2. Over 2, up 4 times 2, which is 8. So let's do that. Let me draw some other lines on here. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. Okay. So over 1, up 1, 2. Put a dot right there. Put a dot right there. Over 2, up 8. Over 2, up 8. Does this parabola look skinnier or wider than my other parabolas? Yeah, skinnier. And this is a pattern that hopefully you remember. The bigger this number is, the skinnier your parabola becomes steeper, right? How would I make a really wide, like bowl-shaped parabola? Yeah, if I had a decimal or a fraction here, that would make the parabola widen out. Questions about this?